Let's talk about something we all kind of take for granted: comfort. You know, that feeling when you walk inside on a cold day and it's just perfect. Well, there's an incredible unseen science behind that feeling, and today we're gonna pull back the curtain on it.
We've all been there, right? There's that one room in the house that's always freezing, or the office where you need a sweater even in the summer. It's super frustrating. But it turns out there's a whole field of engineering dedicated to solving exactly that. And it all starts with a surprisingly simple idea. Okay, I want you to picture this. In the winter, every single building is basically a bucket. A bucket that's trying its best to hold on to all that precious, cozy heat. The problem? This bucket is absolutely full of invisible holes, and warmth is constantly escaping. So the entire job of a heating system is just to pour heat back in, exactly as fast as it's leaking out. It's a constant balancing act.
So, here's our game plan. We're gonna start with this whole leaky bucket problem. Then we'll go on a hunt for where all that heat is escaping. After that, we'll tackle something called the fresh air dilemma, find a really clever way to recycle wasted energy, and finally, see how it all comes together to create that perfect indoor air.
All right, let's dive into that fundamental challenge. You see, keeping a space warm isn't just about cranking up the heat. Engineers are actually in a constant fight against the fundamental laws of physics. And it really all boils down to one simple, unavoidable fact of nature. Heat always moves from a warmer place to a colder one. Always. So on a chilly day, your warm, cozy building is constantly just bleeding heat out into the cold world. That process is called heat loss, and it's public enemy number one for a comfortable room.
Okay, so if we want to fix our leaky bucket, we first have to find the holes, right? This is where engineers become detectives. They use some pretty precise calculations to figure out exactly where and how a building is losing all that precious warmth. And this detective work has basically narrowed it down to three main culprits. First, heat escapes right through the building's skin. You know, its walls, its windows, the roof. It also gets out through tons of tiny, invisible cracks. And, this one might surprise you, it even leaks out through the edges of the floor. So let's look at that first big leak: skin loss. This is just heat passing directly through the materials themselves. To figure out how much, engineers use a formula like this one. It looks at what the wall is made of, that's the U, how big it is, that's the A for area, and of course the temperature difference. So a huge window on a really cold day, that's a massive leak in your bucket. Leak number 2 is something called infiltration, which is really just a fancy word for drafts. You know, all that cold air that sneaks in through tiny cracks around windows and doors, pushing warm air out. This formula helps measure that loss by looking at just how drafty the building is, and again, that all-important temperature difference.
Now, we almost never think about the floor, but it can be a huge source of heat loss, especially for buildings that are built on a concrete slab. Heat is just constantly seeping out from the perimeter where the floor meets the outside world. And yep, there's a formula for that too. It calculates this edge loss by looking at the building's perimeter and how cold it is outside.
Okay, so we've found all these leaks. The logical next step is to seal everything up tight, make the building airtight, right? Well, not quite. It turns out we actually need to intentionally punch another very big hole in our bucket. And this brings us to the fresh air dilemma. For us to stay healthy and for the air not to get all stale and stuffy, we have to bring in fresh air from outside. But on a freezing cold day, that fresh air is, well, it's freezing. The energy it takes to warm that air up is called the ventilation load. So to stay healthy, we've just created a massive deliberate leak in our own bucket. But this is where engineers get really, really clever. They came up with a brilliant solution to this dilemma. The thinking is, if we have to get rid of all this stale, warm air anyway, why not steal its heat on the way out? Now, to really get this, we need to know that air actually holds two different kinds of heat. The first is sensible heat. That's the stuff a thermometer measures, the actual temperature. But then there's latent heat, which is this hidden energy stored in the air's humidity. Think about the intense heat you feel from steam. That's latent heat in action. And the amazing part is, modern systems can capture both. And here's the magic. A heat recovery unit takes that warm, stale air that's on its way out and passes it right next to the channel of cold, fresh air that's coming in. They never mix.
but the heat literally jumps from the warm outgoing air to the cold incoming air, so the fresh air gets pre-warmed, basically for free, using energy we were just going to throw away. It's absolutely brilliant.
And of course, there's a way to measure how well this works. Efficiency. This eta symbol here tells us exactly what percentage of the heat is being successfully recycled. So if a system has an efficiency of 75%, it means it's capturing 3/4 of the heat that otherwise would have just been totally wasted. So now we have all the pieces of the puzzle. We've figured out how much heat is leaking through the skin, the floor, and the cracks. And we know how to smartly recycle energy from the fresh air we bring in. It's time to put it all together. And the process is actually pretty straightforward. Engineers just add up all those individual heat losses from the skin, the edges, the drafts, and the ventilation to get one big final number. This number, Q total, tells them the exact amount of heat the building is losing every single hour. And that means it's the exact amount of heat the heating system needs to produce to keep things perfectly balanced. And here we are, the final piece. We know the total heat we need to add back in, and we know how much air the fans are moving through the ducts. This last calculation tells us exactly how much warmer the air coming out of the vents needs to be to make up for all the losses. It's called delta T, and it's our target temperature change. All of that complex math leads to this beautifully simple target. In the winter, the system just needs to make the supply air equal to the room temperature plus that delta T we just calculated. And in the summer, for cooling, you just flip it. You subtract the delta T. It's that simple, and yet that incredibly complex to get to. So the next time you walk into a building and the temperature feels just perfect, take a second to think about it. It is absolutely not an accident. It's the result of this silent, invisible, and perfectly calculated battle against physics, a system that is constantly pouring just the right amount of heat back into that leaky bucket, all so you can feel perfectly comfortable.